Hello, Math 2 students. Today we're going to take a look at this problem about the function shown represents the height h in feet of a model rocket t seconds after it is launched. What is the maximum height of the model rocket? Well, the first thing that you should notice about this function, h equals negative 16 times the quantity t minus 4 squared plus 256, is that it is in vertex form. Because my function h equals negative 16 times the quantity t minus 4 squared plus 256 is in vertex form, I already know what my vertex is. So I'm going to fill in the middle location on my table with the vertex. And the vertex on this problem is positive 4, comma 256. Now, the 4 is 4 seconds because the t in this problem stands for time, and the 256 is the height. So after the rocket has been flying for 4 seconds, it has a height of 256 feet. Now, because a parabola is symmetrical, I know that the axis of symmetry is going to be at time equals 4. So the axis of symmetry would look like this. I want to know what happens right before and right after the rocket reaches the vertex. So if it reaches the vertex at 4 seconds, what was going on at 3 seconds? And what was going on at 5 seconds? And I want to know what was happening right before that. So what was happening at 2 seconds? And what was happening right after that at 6 seconds? So to start with, I'm going to fill in the height when time equals 5 seconds. So that's going to look like this. So I know after 5 seconds, the rocket's on its way back down and its height is 240. Now, the great thing about a parabola and the fact that it's symmetrical, I know that on the way up at 3 seconds, it was also at a height of 240. Now I'm going to figure out what happens when the height is 6 seconds. That'll look like this. At 6 seconds, our rocket will still be on its way down, and it will have a height of 192 feet. Now, we know that it was also at a height of 192 feet on the way up, and that was at 2 seconds. Since a parabola is symmetrical, and our table will also be symmetrical, so we can see at 2 seconds it was 192 feet. At 3 seconds, it was higher at 240. At 4 seconds, it was at 256. At 5 seconds, it was on its way back down at 240. And at 6 seconds, it was on its way back down in only 192 feet above the Earth. So now we are going to graph our function. So those are the 5 points that we have. And the vertex is 4, 256. And as you might suspect, that is the highest point. So since 256 is in the H column on our table, that's the height. The maximum height of our rocket is 256 feet. But there's some more things I want to know about this graph. Like, I'm curious to find out, was the rocket on the ground when it was launched? So in other words, what was the height when the time was 0? So I'm going to find that out by erasing these points that I already put on the graph, and I'm going to put in a time of 0. When I put in a time of 0, it will look like this. So by doing those calculations, by putting 0 seconds in for t, I found out that when time was 0, the height was also 0, which means our rocket was launched from the ground. And we will have a point on our parabola right here at 0, 0. Now I know there's going to be a symmetrical point on the other side of the axis of symmetry. And that symmetrical point is going to tell us something very important. 0, 0 is 4 seconds away on the x-axis from the axis of symmetry. So if we go 4 seconds on the other side of the axis of symmetry, we will be at this point right here, 8, 0. So our whole parabola looks like this. Here's what we know about the function h equals negative 16 times the quantity t minus 4 squared plus 256. The maximum height of the model rocket is 256 feet. We also know that the rocket is launched from the ground, reaches the maximum height in 4 seconds, and it smashes back into the ground after 8 seconds. That's the end of this problem. One more bonus fact that I'm going to give you right now. I'm going to show you how to change this function, which is in vertex form, into standard form.